Artificial intelligence in smartphones, plant phenotyping for species recognition and health condition identification using deep learning. This paper analyzes the contribution of residual networks or ResNet based convolutional neural networks or CNNs architecture employed in two tasks related to plant phenotyping for species recognition and infection of detection of plants. Plant phenotyping is a technique for quantitative formulation and analysis of complex plant traits, for example, plant morphology, plant stress, crop yield, plant physiological and anatomical traits, and so on. Computer vision-based plant phenotyping techniques offer a non-destructive and efficient representation of the complex plant traits. This article has developed a computer vision-based plant species recognition and health condition identification technique analyzing plant leaf images. In the pre-processing step, inappropriate data images are filtered out and the relevant images are resized, denoised, and segmented to get a more accurate classification result. The next step is feature extraction of the images. Generally, plant parts affected with some disease show deformation in their color, texture, and shape. Classification algorithm learns from the input data features and fits a model which can predict target classes. The whole input data set is divided into training, testing, and validation. Data repository of segmented leaf images of 12 different plant species was selected for this purpose. It has 4,503 images, in which 2,278 images are of healthy leaves and 2,225 images are of leaves infected with different diseases. In the pre-processing stage, representation was changed from RGB to HSV, standing for hue, saturation, and value, colors, and color space. A threshold value, which is added to the V value, which increases the brightness level of the image. Enhancing brightness makes the dark spots on leaves and the infection patches easily differentiable. The dataset was organized as two test cases. The researchers have used the residual network ResNet version 2 based convolutional neural networks or CNNs architecture for classification and compared the species recognition results with something called AlexNet so that the outcome can be used in a wide variety of platforms. The proposed methodology has been implemented using Python. Nine different test cases have been designed to perform the following tasks on 1. Species recognition, and 2. Identification of healthy and infected leaves. For species recognition, the input datasets were classified into 12 different classes that correspond to the 12 separate species. The task of health condition identification of different plants includes the task of species recognition. When similar classes are combined during training, it reduces the number of misclassifications. More training images may enhance the feature discrimination power of the classifier. The leaf image dataset had an unequal number of images present in each class. For example, a minimum of 777 images and a maximum of 345 images. Undersampling and data augmentation methods have been used to deal with the imbalanced dataset and diversify the training set. The dataset with synthetic images achieved a higher F1 score than the dataset with fewer images, 0.6% higher in species recognition and 2.6% higher in health condition and identification. The research and analysis gave an insight into how the performance of the deep learning model changes with the number of classes, the number of images in the training set, depth of the classifier, and the computational time in the context of SR and IHIL. We can conclude that the computer vision-based model health condition detection and analysis of plant diseases and their control in real time will help in increasing the yield of farmers in the near future.